So today what we're going to do is we're going to begin our look at what's called trigonometry. Now we've looked at geometry, right? That is the study of any shape, right? So now we're going to start talking about trigonometry, and TRI would indicate that this is simply geometry with what? Triangles, exactly. So don't let it freak you out that it's trigonometry. It's no big deal. And today, all we're going to do is focus on learning to label what are called right triangles. All right, so we're going to talk about what a right triangle is, and then we're going to talk about labeling them, because if you can't label a right triangle, then you're not going to be able to go any further. That's the bad news. The good news is it's incredibly easy, because all you have to do is know three things, right? Triangle, right? Okay, so we're going to go and just use the Education Perfect lesson for this. So let's go to that lesson. Okay, so we're going to be learning in the complete lesson, not today, about what's called the Pythagorean Theorem. The Pythagorean Theorem is just a way of finding the length of a missing side if you know two of the other sides. Okay? And again, we'll talk about that later. But first, before we do that, we need to talk about the parts of a triangle. Okay? So first of all, what we're going to be working with are something called right triangles or right-angled triangles, either one of those. So make sure that you are writing anything that I underline or write on. So right-angled triangles will be our focus for this particular course, right? So if it's not a right-angled triangle, then you cannot use the methods we're going to be showing you, right? This is very specific to right-angled triangles. And you may remember that a right angle means an angle that is exactly 90 degrees. So think a perfect corner, like where the wall meets the other wall or the floor meets the wall. So it makes a corner. So you get a right triangle. Now, often they won't tell you that it's 90 degrees. Instead, they'll simply draw a little square in the box. Because remember that every angle of a square is a right angle. So if they draw that square, that says that angle has to be 90 degrees. Yeah? So right-angled triangles are triangles that have one angle that is exactly 90 degrees. You can't have more than one angle of 90 degrees. It's too big. Because what do all the angles of a triangle have to add up to? 180 degrees. Yes. Good. Okay? And again, watch out for that little square in the corner. That tells you that it's a right triangle. So, remember again, there can only be one of them, but here's an example, a drawing, where you can easily tell that this is a right triangle by simply seeing that box there. Unless they tell you that one angle is 90 degrees, or show you that, put that little box in there, that drawing in there, you must not assume that it's a right triangle. Okay? You must know that it's a right triangle. Now, they can give it to you in other ways. Say you have a post coming out of the ground. That's assumed to be a right angle, as long as we assume the ground to be perfectly level, right? They'll also do it with a tree growing out of the ground, although that's rarely a perfect right angle, right? But we consider it to be for mathematical purposes, all right? Good. So they have to tell you, or it's got to be an application type of problem. There are specific parts of a triangle that have specific names, and the most important one is the hypotenuse. So know that word, okay? Hypotenuse. The hypotenuse is simply the longest side of a right-angled triangle. And remember, what I'm underlining is what you should be putting in your notes. The hypotenuse is simply the longest side of a right angled triangle. It's also always the side that is across from the right angle. Sometimes it's difficult to see which side's longer, but if you just look at the one that's opposite of the right angle, that's always the hypotenuse. It has to be, okay? So wherever that square is, the side that's opposite that square doesn't touch the square, that has to be your hypotenuse. Okay?
So it's just the longest one?
Mm-hmm. Right. So, two ways to identify it. It's the longest one, or it's the side directly across from the right angle. That is the key to making all of what we're going to do this whole lesson, this whole section work. If you can't identify the hypotenuse, then you're sunk. Okay, so make sure you can identify it. Okay, fill in the gaps using the hints. The hypotenuse is the longest side. Excellent. Of a what? Right angled triangle. A right angle is exactly what? 90 degrees and is labeled by a small square. Excellent. Oh, okay.
Yes.
I think we got that one right. Okay. Select all the triangles that this applies to. Remember, it only applies to right angled triangles. So which ones? 1 and 4. None of these don't even look like right triangles, do they? What if it did look like one and it did not have the square? Could I have selected it? No. You must be careful. Okay. All right. I'm on fire. Yeah. Okay. True or false? This pool rack forms a right angled triangle.
No.
False. Okay. True or false? This ruler is right angled. True. Excellent, guys. Okay. True or false? This sign is a right triangle. False. True. False. True. Maybe.
It has a circle, but it looks like a right angle. False.
It's probably true. Let's check it to be sure. Yeah. Okay. Yeah. You just have to know that it's a funny little shape, but it's all right. Okay? All right. The next thing we want to talk about is labeling the sides. And this is, again, a key skill. If you can't tell me which side's which, then you're not going to be able to make the pattern work, the formula work. Okay? But again, we only have 3 sides. And one of them we've already talked about. What's it called? Hypotenuse. That's the longest side, or the side that's directly across from the right angle. Okay? All right. Well, we normally label these sides. Okay? So in this case, which one of these is the hypotenuse? C. C is the hypotenuse. But with the Pythagorean formula, we usually label them A, B, and C. Right? Where C is always the hypotenuse. It cannot be any other side. Okay? So C is specifically reserved for the hypotenuse. A and B are simply the sides. And since they are both sides, does it technically matter which one's which? No, not at all. So I could just as easily have written A here and B there. It literally makes no difference whatsoever. Okay? So it doesn't make any difference which side you call which. Traditionally, this one would have been A and this one would have been B because this one is shorter than this one. Right? But again, who cares? Right? So remember that the hypotenuse must be the hypotenuse, but the sides can be either number. Either letter, A or B. Okay. But it's always A, B, C, where C is always the what? Hypotenuse. And A and B matter? No, you can interchange. They're interchangeable. Good? Yeah. All right. Oops. Let's see what they do next. Okay. So again, they're just reiterating that A and B can be switched. It doesn't make any difference, but C has to be the hypotenuse. And remember, the hypotenuse is always the one across from the right angle. For consistency, they're going to use the convention that B is the vertical one, A is the horizontal one. I don't care. Right? So, but if they're telling you that they're going to use B as the vertical one and A as the horizontal one, when you're doing them on Education Perfect, they may count them wrong if you don't. So you might want to follow that pattern. Traditionally, for the Pythagorean formula, you'll use A and B. But then when it's not that, you can call it anything you want to. Okay? All right. So let's just go through and label some of these. Is the following triangle labeled correctly according to their process?
Yes.
Yes.
Well,
A is the horizontal, B is the vertical, and C is the hypotenuse. So what you're supposed to be seeing from this particular thing is that the orientation of the triangle doesn't matter, right? You would still use the same conventions for labeling. Okay? Excuse me. All right. So again, the orientation of the triangle, in other words, it can be turned any direction, that does not have any bearing at all about the labeling, right? So if you want to rearrange them, then you can. Let's just check. There you go. Right? Again, they used B as the vertical, A as the horizontal, C always the hypotenuse. Okay. Is this one labeled correctly?
no.
What is glaringly obvious? C is not in the right spot, right? So C and B are not in the right spots. So that should be C, that should be B, if you set it on its edge with A on the bottom, right? Okay? It's good? Y'all are good answering those questions. Love it. Okay? Labeled correctly?
No.
What's wrong with it?
C.
Yeah, A and C are reversed in this one, aren't they?
Yeah.
Okay?
Sure.
Right? C should be on the other side and A should be. The C is. Labeled correctly?
Yeah.
Yes. Okay. All right. So, that's our lesson for today.
Can we play games now?